Good evening, everyone. Just a moment. So, very good evening, all of you guys. Welcome to Unacademy. Welcome to the Kreatryx channel. So, welcome to our course of the Brahmastra crash course on network analysis. Today is the last class of this batch, most probably. Uh, and we are going to cover the leftover topics. So, कल तक हमने AC analysis में basics तो cover किया, जैसा AC phasor representation, steady state analysis of the AC, and we have discussed the phasor diagrams and resonance. Now, we will discuss some part of the power calculations, average RMS values. Then we will go for the last part, that is magnetic coupled circuits and this one, three-phase circuits. Okay, so let's move further. So I hope you know Unacademy uh, is offering you the highest possible discount or highest ever discount on the Plus subscription right now. You will be getting 23% off on an Academy subscription by using my code Shankar10. So if you have a plan for taking the subscription, don't delay it further, guys. If you want to take the subscription, take it as early as possible because the offer is for the limited amount of time, limited period of time, and also use the code Shankar10. So these are our toppers this year for the ESE examination from an academy, electrical and EC engineering. So this is our batch for Udan batch that is going to that is already started on December 21st by Umesh sir. Daily it is going on at 7 p.m. in the evening. So if you want to start your preparation journey for 2024 and 2025, this is the right batch to start your journey. So yesterday we have started this AC analysis. I have already completed this part. So today I'll cover this part and yeah, these two parts. Okay, so जनरली रेगुलर क्लास में एवरेज आरएमएस वैल्यूज फॉर कैलकुलेशन के लिए कम से कम मैं 2 घंटा टाइम लेता हूँ बट यहीं पे ऐसा नहीं ठीक है क्विकली वी विल बी आई विल बी एबल टू आई ट्राई टू कवर. Yesterday we are done with this part. Now average RMS values and complex power calculations. Okay, right. So let's start this. So for a periodic signal, we define the average value as 1 by t integral 0 to t x of t dt. You can also define this as area over one time period by the time period. Area is given by the integration. The next one is RMS value. We call root mean square value. It is root of mean means 1 by t integral 0 to t of x square of t dt. Okay, this is the RMS value. So, fine. If you have a basic signal like this, here few important shortcuts I'm giving you. If signal is half rectified, that is area reduced to half, RMS will be multiplied by 1 by root 2. 1 by root 2. Similarly, if x1 not equal to x2, but x1 square equal to x2 square, you see here x square we are finding the RMS value for the square of the signal. No? So then x1 RMS always equal to x2 RMS. Okay. Next, integration of 0 to t cos omega t dt is equal to integration of 0 to t sine omega t dt. Area of the sine or cosinusoidal signal over one time period is equal to 0. And the next point, for a DC signal, average value equal to RMS value equal to its magnitude. Next, for a sine or cosine of any phase, I'm not going through the derivation, just substitute that in the formula, you will be getting it. Or frequency, average value equal to 0 and RMS value equal to maximum by root 2. So integration of cos omega 1t into cos omega 2t is also 0, provided omega 1 not equal to omega 2. But cos square t equal to 1 plus cos 2t by 2. That if you substitute here, that 1 by 2 will come as Vm by root 2. Okay. Now, these are the things. So now listen here. By using these concepts, if you have a sine wave, basic, say this is the sine wave, right? What is the average value is given by 0. Sometimes we also give it as a 2Vm by 5 if half time period is considered. Okay. What is the RMS value of this? Maximum by root. Okay. Here, what is the average value? 2Vm by 5. Okay. What is the RMS value of this signal? Sir, I can say the RMS value of this signal from this signal, sir, because I square this and square this. They are same, sir. When the square, after squaring, if the signals are same, RMS value must be same, sir. So here it will be Vm by root 2. Similarly, here area is reduced by half, sir. It is called half rectified signal. Average value reduced by half. RMS value should be multiplied by 1 by root 2. So that will give me Vm by 2. Okay. So this is the first part. The same way we can do it for So this is A, A minus A. Height is A. इस केस में what is the average value? For DC it is same as magnitude. What is the average value here? Sorry, I am saying average, RMS. What is the RMS value for the DC signal? Average value equal to RMS equal to its magnitude. What about its RMS value, sir? Sir, here the signals are different, but if you square this one and this one will give you same answer, then RMS must be same. Then what about this one, sir? This one half rectified, na? RMS will be 1 by root 2 times its value. ठीक है sir, हो गया, fine. Now let me give you little more theory. I may take few more minutes for the theory, then we will move for the problems. Okay, now let's move for the triangular waveform. All the standard signals I am giving you. This is A. This is also A. This is also A and minus A. Okay. So here, what is the XRMS is? A by root. From this, what is the XRMS mean? So half rectified A by root 6. What is the XRMS here? If you square this signal and this signal, you get the same answer. So it is A by root. Okay. So that is how we can find if you have one basic signal information, you can find first. So for a square wave, it is A. For a sine wave, A by root 3. For triangular wave, it is A by root, sorry. For a square wave, it is A. For a sine wave, it is A by root 2. And for the triangular waveform, it is A by root 3 for the standard signal. After that, from that, you can find for other. Okay. So that is about your basics of the average and RMS values. And let me give you a few more things. Okay, x1, x2, x3 is a signal. Then what is x? X equal to sum of three signals. What is x average? X average equal to x1 average plus x2 average plus x3 average. No problem, because sum of average integration of a whole or individual is same. What is XRMS? Is given by root of x1 RMS square plus x2 RMS square plus x3 RMS square if omega 1 not equal to omega 2 not equal to omega 3. Okay, and also all signals average must be 0 except ADC. Okay, if omega same, simplify first. This we discussed in the regular class, but just I'm quickly giving as a revision. If you have sum of three signals or two signals or four signals as a what we call your signal, इस केस में overall RMS equal to root of squares of individual RMSs. इसमें exception तो ये होना चाहिए, वो orthogonal signals होना चाहिए यार. इसका मतलब here this must be sine or cos or DC only. Don't apply for other. Or you can apply it provided you have a zero average value signal also. You can do it because तो a प्लस बी प्लस सी होल स्क्वायर का इंटीग्रेशन करना चाहिए. ए स्क्वायर प्लस बी स्क्वायर प्लस सी स्क्वायर आएगा अंदर. तो 2ab 2bc 2ca जो होता है ना, इसका इंटीग्रेशन जीरो होना चाहिए. कब होता है सर? व्हेन इट्स एवरेज वैल्यूज आर इंडिविजुअली or after multiplication they must lead to zero. Okay, so when omega 1 omega 2 are same, this will not happen. Sin square theta will come in the integration of inside when the signals of same frequency. So when signals are different frequencies only, apply this formula. Okay, so let's go back. We have a question. Yep. Okay, so the current, yeah, find IRMS. Okay, this is the question. Find IRMS. Okay, आप लोग कमेंट करना चाहे तो कमेंट कर लो, नहीं है तो मैं सॉल्व करके देता हूँ. सो प्लीज गिव ए ट्राई. If the elements are not lumped, you cannot apply KCL, KVL, any other rule. Then you should take the distributive nature into consideration and you should apply your electromagnetic field theory का concepts. Anindya Bose, why average power is VRMS, IRMS cos phi? Because it is a crash course, I cannot derive, but I can give you hint. Okay, what is the average value of any signal? 1 by t integral 0 to t x of t dt. Okay, Anindya Bose. So 1 by t integral 0 to t power p of t dt. Now 1 by t integral 0 to t, say v is equal to vm cos omega t plus phi 1 and I is equal to Im cos omega t plus phi 2. Just to substitute this and find it, then finally you will be end up with VRMS. You get Vm Im by 2 cos phi, where phi is equal to here phi 1 minus phi 2 if you take it into consideration and apply here this one. Just substitute this, you will get it. मेरा regular class में इसका derivation मैंने किया, एक बार check कर सकते हैं. कोई भी टेस्ला बैच और लक्ष्य बैच का ओवर कैलकुलेशंस टॉपिक में मैं तो ऑलरेडी सॉल्व किया, बट हियर आई डोंट सॉल्व और आई डोंट डिराइव, मैं तो डायरेक्ट डेरिवेशन देता हूँ. ठीक है, you may get the doubt. Generally average power means why can't we take voltage average into current average? Overall average is never equal to sum of multiplication of individual averages. It is true for some because integration of x1 plus x2 is integration of x1 plus integration of x2. Integration of x1 x2 will not be equal to integration of x1 into integration of x2. So don't multiply individual averages. ठीक है, इसका IRMS कैलकुलेट कर सकते हैं अभी. So from there only the RMS concept will evolve. Okay, I mean, so what is the IRMS is root of 3. Firstly here omega 1, here omega 2, not same na. So 3 square plus 4 by root 2 whole square plus another 4 by root 2 whole square. Here integration of a square plus b square plus c square, 2ab का integration 2bc का और 2c का integration 0 हो जाएगा. That's why this formula. If you need I average, for a DC it is 3, for AC it is 0 or 0. That is bus. Right. Okay. चलो, this is done. Okay. That is about your average and RMS values. So let me give you little information regarding power calculations. Okay. Here also as quick as possible मैं तो cover कर रहा हूँ. ठीक है. Here true power or active power or real power or average power. P is given by VRMS, IRMS, constant. Here VRMS, IRMS are source का powers. Phi is angle of V by angle of, that is the source का total network का source का लेना चाहिए VRMS, IRMS. नहीं है तो you can also take voltage across the resistive part of the network if it is a simple RLRC circuit by R, or if you have only one resistor the IR square into R, but compulsory आप RMS ही लेना चाहिए. मैं तो derive नहीं कर रहा हूँ. ठीक है. So units for this is watts. The next one reactive power. Reactive power का दूसरा नाम क्या? Imaginary. That is the power taken by, here previous one is the resistive part of the load, here it is the power taken by the reactive part of the load. It is not the power dissipated. Okay. In fact it is the power converted we can say. So V x square by x हमेशा 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 RMS से होना चाहिए. I x square into x. Units are volt ampere reactive. Actually there is a units में कोई difference नहीं, because VRMS IRMS phi का कोई unit नहीं cos phi sin phi का, but to differentiate it we represent with VAR and watts, because we should understand the difference ना which power it is, इसलिए हम ये करते हैं. ठीक है. So this is the one. Now the complex power S equal to P plus or minus JQ. Plus means for lagging power factor, minus is for leading power factor. ठीक है. And the mod S is called apparent power. Root of P square plus Q square. Units are volt ampere. ठीक है. There is one triangle called power triangle. P, Q, mod S and phi. Power factor equal to P by S. That is cos phi. Similarly, what is here? Sin phi Q by S, tan phi Q by phi. Okay, these are the rules. If you know, you can solve most of the questions of the power calculation. So let's solve that. You can also write power is equal to S equal to V into I conjugate, because the angle should be subtracted now, V and I, इसलिए conjugate लेना चाहिए. Power equal to real part of VI conjugate. Q equal to imaginary part of VI conjugate, where V equal to VRMS angle phi 1, I equal to IRMS angle phi 2. Overall phi will be phi 1 minus phi 2. ठीक है. चलो, that is about the basics of the power calculations. रेगुलर क्लास में इसके लिए कम से कम 1 घंटा डिस्कशन करना चाहिए, प्रूव करना सभी चीज, बट यहीं पे एज फास्ट एज पॉसिबल मैं तो कवर कर रहा हूँ. ठीक है. प्रॉब्लम्स एक लग सकते हैं. So the first question here, for the circuit shown in the figure, the power supplied by the source. So please give a try and tell me the answer. Take your time, 1 minute. Okay. So for the circuit shown in the figure, the average power supplied by the source. Okay. So this is VRMS. Okay. Find IRMS and also cost by. इसके लिए पहले आप क्या करना? You can also do like this. Minus it. Find the input impedance. Right? Sure. So Z in equal to J2, okay, plus, otherwise we'll do one thing. Easily we can solve it like this. So V2 say na, find the VR. What is VR? VR minus 20 by J2, VR by 2, VR by minus J2 equal to 0. Okay. So then 2 तो cancel हो जाएगा. So minus J VR minus J into plus J20 plus VR. So plus J VR equal to 0. So plus JVR minus JVR cancels. What is your VR? It is 20 angle minus 90 degrees. So what is the magnitude of the VR is 20. Power is equal to VRMS. VR ka RMS value whole square by R. Only one resistor. No? So what is the answer? 20 into 20 by 2. Okay. So that will give me 400. 400 is not available in the option. It means in this question, this is the right answer, guys. In this question, examiner has taken VR is equal to 20 angle minus 90 degrees. Right? He has taken this as a maximum value because he has not specified as 20 by root 2. Then what is the P? 20 by root 2 whole square by 20 into 20 by 4, 100 is the answer. Okay, but as per exam, most of the cases this will be the right answer. Okay, options में नहीं है इसलिए मैं 100 पे गया, नहीं है तो compulsory assume it as RMS value only, nothing is specified. In GATE exam, most of the questions when you solve assuming RMS value, definitely you get the answer. But sometimes in some, because both are true according to different textbooks, some people will take maximum, some people will take RMS. You can also do like this, VRMS in here current IRMS into cos phi. How to find the angles, that will be little mathematical part करना चाहिए. पूरा input impedance निकाल के इससे ZL निकाल के इससे angle निकालना चाहिए, then current निकालना चाहिए. सभी चीज के लिए time लगेगा. Okay, that is current angle, voltage angle का difference जो होता है ना वो phi देती है आपको. इससे ज़्यादा time लगेगा. This is the easiest way. चलो next question. V of t Gta. Okay. Then the average power dissipated. It is also a similar model question, है ना? So try कर लो यार. Good. So So don't know. See, some people, sir, V square by R directly ऐसा मत करना भाई, ठीक है? You should take the voltage across this element. Okay. After getting this voltage only you should do. Don't directly supply 20 square by 2 करेगा sir ऐसा नहीं. I know after calculation VR I understand it as 20, then only I apply 20 square by 2. Don't apply directly 20 square by 2. Chalo, this question. Some people will do directly V square by R, 100% wrong answer. We should do VR square by R or V square. If you want to find, use V, VI cos phi you should use. Okay. So what is the average power dissipated by the 1 ohm resistor? इसके लिए का हम see here two sources of different frequencies are acting simultaneously. हम क्या करना चाहिए sir? We should apply one source at a time. We should apply one source at a time. And here, uh, firstly, I'm doing omega equal to 1. Okay. Then 10 root 2 angle 20 degrees. 1 ohm J1. इससे करंट I1 निकाल. Okay. I1 equal to 10 root 2 angle 20 degrees by 1 plus J. That will give me I1 of T equal to, directly I am writing 10 root 2 by root 2 चलेगा 10 angle ये 45 ऊपर चलेगा तो minus 25. So because I have taken sign, I'll write the signal as 10 okay 10 sin t minus 25 degrees. This is I1. Similarly I2 भी निकालना चाहिए. Okay, and here what is the power P1? VRMS IRMS cos phi na. So VRMS IRMS. Sir, can I apply superposition? Yes, when two signals are orthogonal, you can apply it. Okay, normally I say superposition is not applicable for power calculations, na, but here it is applicable because here x1 plus x2 whole square integration is equal to integration of x1 square plus x2 square, because integration of x1 x2 will become 0. So that part will remove the RMS value. Okay, इस केस में integration of x1 plus x2 whole square is equal to integration of x1 square plus integration of x2 square if integration of x1 x2 equal to 0. उस केस में what happens, overall p equal to p1 plus p2 वाला सुपरपोजिशन अप्लाई कर सकते हैं, ठीक है, क्योंकि sum of RMS and individual RMS square will be same, that is a plus b whole square into r and a square into r plus b square into r will give you same, right? VRMS IRMS cos phi, voltage angle minus current angle, that will give you 100 by 250. Okay, similarly find P2 also. If omega 1 omega 2 same, don't apply this. Okay, similarly here what is that omega? Ten root 5 cos 2t plus 10 degrees. 10 root 5 angle 10 degrees. That is 10 root 5 angle 10 degrees by 1 plus j2. That will give me 10 root 5 by root 5 angle. Tan inverse of 2 is 63.43 degrees, so it will give you minus 53.43 degrees. Okay. So here this is your I. So here power P2 equal to VRMS okay into IRMS. What is IRMS? Is 10 by root 2 cos of uh, voltage angle minus current angle. Just a moment. Cos of impedance angle only. This one. So this calculation, I don't have that part. If you do it and add, you get the final answer. If you require, just I can also do that. Cos. So this will also around 50 and total will be 100. Anybody have doubt? Please ask. Total VRMS equal to here root of squares of individual ERMS. That is one formula. That is you want total VRMS equal to. अभी तो discuss किया ना इसके बारे में. Total VRMS चाहिए तो root of 10 root 2 by root 2 is 10 root of 10 square plus 10 root 5 by root 2 whole square. Okay, sum of squares of individual. Like that you find individual currents. इसका RMS ऐसा भी solve कर सकते हैं. Time लगेगा. ठीक है. Right. Chalo, next. So what I have done is I have taken only one source at a time. I applied the superposition. And what is the rule where you can apply superposition for the power calculation? Normally superposition is not applicable for power calculation because I1 plus I2 whole square into R is not equal to I1 square plus I2 square plus, so why superposition is not applicable in the power calculations? Let me show you that. I1 plus I2 whole square R is not equal to I1 square plus I2 square. Yes or no? That's why superposition not applicable for power. But for DC this is the case. But AC में क्या? Yes, this can be applicable. When I1 plus I2 का RMS, okay, I1 I2 का RMS equal to I1 RMS, okay, whole square equal to I1 RMS whole square plus I2 RMS whole square. if this is true, yes, this is true, yes or no? If you take this other side, you get the root here, yes or no? This is true if omega 1 not equal to omega 2, right? In that case, yes, P equal to P1 plus P2 is true. Understand what I am saying? Okay, because this in this case, why how it is possible, sir? That is RMS may we take the integration. This is true if integration of I1 into I2 equal to 0. Okay, and that particular because integrate RMS may we find root of I1 square plus root of I2 square, root of integration of I1 square plus integration of I2 square plus integration of 2 times I1 I2. When that part equal to 0, you get both will be equal. In that case, P equal to P1 plus P2 can be applied. I have applied the same. Right. So the next topic is exclusively for electrical engineering. अगर EC स्टूडेंट्स है तो आप लोग जा सकते हैं, आपका सिलेबस तो खत्म हो गया भाई, ठीक है. इलेक्ट्रिकल बच्चों के लिए we will be discussing few topics now, ठीक है. That is exclusively for electrical engineering students only. So the magnetic coupled circuits. So these are the circuits in the presence of the mutual inductance M, which is due to the mutual flux phi. When you have a current carrying conductor, there will be flux linkages, which we call self. Due to that, you get voltage induced across the coil, self-induced EMF voltage. But when you have a coil here, you have the flux magnetic lines, and I bring another coil in the near vicinity, and these lines will cut this coil also, and it will produce some induced EMF. Then it is called as mutual induced EMF. So mutual induced EMF जो induce हो रहा है ना other coil में, it might be additive or opposing to the self-induced EMF of the original coil. Okay, it has some current, it will have some EMF. It has some current, it has some EMF. When I bring it together, it affects this, it affects this. That effect can add the voltage or reduce the voltage. It depends whether the lines are additive or opposing to each other. That is represented with the help of dot polarity. So if current is what we call entering through dot or leaving through dot in both the coils, then it is additive. Otherwise, it is opposing. So as simple as this one, this is additive. Current leaving through both the dots. Similarly, this is opposing. Okay. So here, another important rule, if the current is entering through dot in one coil, the mutual induced EMF is positive at the dot of other coil. If current is entering through dot in one coil, wherever the dot is present in the second coil, there we should take the positive. If current is leaving through dot in one coil, then wherever you have the dot, there we should take the negative. I can also show with the help of the rules, like when the coil is like this, if it is coming from bottom, all those things I did already in my regular class. You can go through that. Okay. So current is leaving through the dot, wherever the dot is provided by the examiner, there you should take the negative. And if the current is entering through the dot, then wherever the current dot is given, there you should take the what we call positive. So there are some interconnections. Quickly, I am showing you the results directly. This is called series connection. First one is AD. Okay, here what is V1 means self-induced EMF, that is due to always current in the same coil, plus mutual induced EMF, which is due to the current in other coil. But here I1 is equal to I2. V2 equal to L2 di2 by dt, self-induced EMF plus mutual induced EMF, which is the current in other coil. So here, what is V? It is equal to V1 plus V2 equal to L1 plus M plus L2 plus M into di by dt. That is L1 plus L2 plus 2M into di by dt. We call this as L equivalent. Okay, similarly, if current is entering through the first dot and leaving through the second dot and they have the mutual inductance M, L equivalent will be L1 plus L2 minus 2M. These are the basic connection called series connection. This one is opposing, the first one is additive. Okay, chalo next. Parallel connection में what is your V1 is L1 di1 by dt. Okay, current is entering to that coil dot, another dot may be entering plus M into current in the other coil di2 by dt. Here the final you can try by Laplace or you can try by phasor analysis, whatever may be. Okay, you can also represent this equation with the help of this figure without dot. You can prove this V1 equal to V2 because parallel and I equal to I1 plus I2. And if you find V by ratio, which will give you the L equivalent, the formula here is L1 L2 minus M square by L1 plus L2 minus 2M. For opposing, it will be similarly for opposing L1 L2 minus M square by L1 plus L2 plus 2M you will get. Okay, that is about the series and parallel connections. Next, transformer connection. Transformer coupling में here V1 is equal to, see, current is entering through the dot. At the second dot, we should take positive. I have already taken in the same way. So this case is additive, plus होता है भाई. So the mutual will add to your original. So here V1 equal to L1 di1 by dt plus M times current in the second coil is di2 by dt. And you can replace this with a transformer two-port network equivalent like this star L1 minus M, M, L2 minus M. I can prove it also with the help of equations in both the cases will give you same. नहीं है तो you can convert this star into delta also and prove it. Okay. So similarly, if it is opposing, for opposing, what happens? Current is here entering through the first dot and leaving through the second dot. Okay, or here entering through the dot now, at the dot you should have positive, but you have negative now means it is the VM will be positive here, that is opposing to this. Okay, is it clear? Current is entering to the dot, at the other dot you should take positive means VM will come with opposite polarities of V2, that is additive 9 opposing hai. So V1 here is equal to L1 di1 by dt minus M di2 by dt. So V2 L2 di1 by dt minus M, so L2 M di1 by dt. Here equivalent will be L1 plus M, L2 plus M minus M. बस ठीक है चलो. Coefficient of coupling is called the degree of the coupling between the two coils. K is given by M by root of L1 L2, where K is in the range of 0 to 1. When K is 0, M will be 0. There is no coupling between the coils. When K is equal to what we call M is equal to 1 is the maximum value you can get. That is sorry, K equal to 1. What is the value of M you can get is the maximum root of L1 L2 tightly or perfectly coupled. You can also have one more thing. If you have transformer with a turns ratio N1 N2, it is loaded with a load impedance ZL. What is the input impedance seen by the transformer is given by the formula N1 by N2 whole square into ZL. I'm not going through the proof. Okay, here because the relation is V1 by V2 equal to I2 by I1 equal to N1 by N2. By using this relation V2 equal to IZ2 ZL and you need to find V1 by I1, you can definitely prove this. It's not a big deal. Okay, but this is the formula N1 by N2 whole square into ZL. So by adjusting the value of N1, N2, I can make my input impedance to my required such that maximum power transfer can be obtained. So let's try this question. Give a try. Right. Here, the transformer A and B such that the impedance is resistive, okay, equal to 2.5. Omega equal to 5000. So I can replace with J5. 1 by J omega C. J 5000 into 10 power minus 5, which will give me minus J20. So this is minus J20. Okay. So here, what is the impedance? I'll get N1 by N2 whole square into 2.5. Here, what is the impedance? I'll get N1 by N2 whole square into this part, that is J5 plus 1 by A square into 2.5. So what is the input impedance you are getting? It is minus J20 plus J5 by B square plus 1 by A square B square into 2.5. This is equal to 2.5 as per required part of exam. So make this part equal to 0. So here J20 plus J5 by B square equal to 0. 20 equal to 5 by B square. आपका B square equal to 1 by 4 और B equal to 1 by 2. Then similarly 2.5 by AB whole square equal to 2.5. So AB must be equal to 1, A equal to 1 by B, that is 2. Thus A must be 2, B must be 0. Okay, option B is the right answer. This question you can give as a homework because you don't have sufficient time to solve it. Answer to -5 and -0.5 because it is a combination of transient also and this one also. So give a try for this short question, easiest simple question. Right. So two couples are connected in series. Uh, Connected in series have the equivalent inductance of 16 or 8 million depending on the connection. So series में what is the possibility is L1 plus L2 plus 2n, L1 plus L2 minus 2n, because the maximum will come when you have this and this. Okay, so if you take the equation 1 and equation 2, subtract 1 from 2, you get 4m equal to 8 millihenry. M will be 2 millihenry बस, because ज्यादा कब मिलेगा आपको 82 में, कम कब मिलेगा अपोजिट में. टू पॉसिबिलिटीज आते हैं. थोड़ा सा टाइम लगने वाला क्वेश्चन है. What is root of L1 L2? Just a moment. So what is the inductance formula? Mu square n1 n2 a by L. Okay, so proportional to n1 n2, correct, right? Inversely proportional to L, correct. What is area? Pi r square. It is proportional na. Fourth wrong है. So 1 2 3. Mu n1 n2 mu n square. ठीक. Next, similar model. One more question. Okay. If the mutual inductance describes the voltage induced at the end of a coil due to magnetical field generated by the second coil, right? Dot convention allows a sign to assign to the voltage due to mutual inductance. ये गलत है ना, A equal to m by root of L1 L2, ठीक है? बस. Here, actually the question is complex. At least I should give you the approach and answer. Okay. So how to solve this kind of questions I am giving you. Firstly, V1 by V2 equal to N1 by N2 equal to I2 by I1. Okay, I2 is the leaving, I1 is the entering. Okay, this is the first part. Now, I will give you the necessary equations, you solve at home at least. Approach to be, you should know. So 300 equal to 60 I1, okay, and plus V2 plus V1. Here this is I1 minus I2, I1 minus minus minus. Okay, 60 I1 plus V1 plus I1 minus I2 into 20. This is one equation. The second equation in this loop is 0 equal to, okay, minus V2 plus I1 minus I2 into 20. Okay, I2 is in this direction, current enters from positive, is from negative, plus minus 40 I2. Okay, you can use this and find the power. Power equal to I1 minus I2 whole square into 20. Okay. Here you can use the relation between I2 and I1 because here L1 L2 values nahi diya na, you cannot use the formula L1 dI1 by dt plus M dI2 by dt. Only ratio is given. Okay. So here V1 by V2 ka ratio to diya na, so I can eliminate that variable. And also see here, firstly, if you substitute, I mean, you have V2 here, right? Okay, fine. Leave. Simple thing. What is V2? 4V1. So replace V2 with 4V1. And 4V1 from here you find V1 keeping this side and substitute that also. Then you get I1 minus I2 ka value is square into 20. You get the final answer. And not doing that mathematical part, you can do that. Okay. Similarly, here also you need to find the V1 by I1. Use the Laplace transform concept. This is S. This is S by 4. This is S by 3. Okay. So originally the formula will be like this. V1 equal to L1 D. Sorry, L1 is yeah, L1 dI1 by dt. Here current is entering na, plus M12 dI2 by dt plus 2 times I1 plus I2. This will be, what is that? SL1 plus SM plus into I1 plus 2I1 plus 2I2. Okay, here L1, L2. L1 is how much? 1. L2 is equal to 1 by 4. M is equal to 1 by 2. I'm just giving you the approaches at least such that you can do the equation. So take the KVL in this loop also. Say I2 is in this direction, current enters from positive, this from negative. So positive to negative minus SL2 because positive to S is d by dt indirectly. L3, SL3. Here this is L3. Okay. Positive to negative minus what is that? SL2. Okay. Plus M12 into S because L2 di by dt plus M di1 by dt. Okay. SL2 1 minute. One. See, yes, L3 into this is I2 of S plus S into L2 into I2 plus M into M between 1 2 into I1 of S plus I1 plus I2 into 2 equal to 0. Okay, this is equation 2. This is the equation 2. Solve and find V1 by I1 ratio. It will take time. Calculation करके check करो 2 by 3 आएगा. Okay. So process तो दिया ना मैंने. So this is how this evolves. Here हमें तो directly equation लिखा. For this there is no mutual coupling here. Directly self लिखना. ये दोनों को लिए mutual भी लिखना चाहिए. बस. So last 5 minutes. ये क्वेश्चन ट्राई करो यार, बहुत इंटरेस्टिंग क्वेश्चन है. ठीक है, कैसा करना चाहिए तो मैं देता हूँ. फर्स्टली t इक्वल टू 0 माइनस में नेटवर्क का रेस्पॉन्स निकालो. ठीक है, दैट इंफॉर्मेशन इज ऑलरेडी गिवन बाय एग्जामिनर इन दिस नेटवर्क शोन इन द फिगर. टू सेकेंडरीज, all the three windings are same number of turns with the polarities given by examiner. This is the positive and all. The switch is opened at time t equal to 0 before the 0. Okay, so capacitor को when the capacitor is charged with 5 volts, here 5 volt already present है. By using the what we call they are equal ना, here also 5 लेना चाहिए. Resistance 10 है ना, 5 by 10 will give you 0.5 ampere as the inductor initial current. Now examiner asks you after opening the switch. Here inductor current cannot change instantaneously. Here capacitor current cannot change instantaneously. As per examiner polarities find out करो, आपको -5 and -0.5 मिलेगा. ठीक है. एग्जामिनर को आई थिंक वीपी चाहिए because the turns ratios are same na. Here whatever the voltage you have, same voltage will come here. So t equal to 0 minus, what happens, the switch is closed na. But here examiner given polarities, we should follow that. Actually all dots should get same positive, but not given by examiner, we cannot oppose him. Okay, here this is the resistor. Here he got this much voltage. Okay, capacitor voltage, the same voltage you can take here, taking all dots same, and R equal to 10 now, 5 by 10, 0.5. Okay, so this is the inductor initial current, 0.5. I think 5 and 0.5 will come. The switch is opened at time t equal to 0. Okay, according to him, dot में negative है ना, here also reverse. This will be minus point. All dots should have same polarity. T equal to 0 plus, all dots must have same, because capacitor voltage cannot change instantaneously, inductor current cannot change instantaneously. So capacitor acts as a voltage source of 5 and inductor acts as a current source of previous value. What is the current source value? Is direction पे minus 0.5. So inductor acts as a current source. Because it is minus 5, this is also minus 5. So minus 5 and this current is minus 0.5. Inductor current and capacitor voltage cannot change instantaneously. I thought of giving homework but मैं solve किया यार. ठीक है. That is your coupled circuits का questions. And is it visible first? Let me check. Just a minute. Last topic, three-phase circuits. So balanced three-phase circuits. And this is the last topic. Okay. So अगर possible in the available time अगर possible है तो कुछ कर सकते हैं ना, ठीक है. So here you have the balanced three-phase circuits in your what we call syllabus. So three sources of equal magnitude with phase difference of 120 degrees. This is called positive sequence. Here impedance is also same magnitude होना चाहिए, same phase होना चाहिए, so that you get the same currents of same magnitudes with 120 degrees phase shift. Okay, and here the important relations. These are some fundamental definitions. What is the line and definition of the phase current and a colors to not visible. I am sorry for that. Phase voltage is the voltage between the terminal and neutral. Terminal means of the source or voltage across one source or one load. Okay. So similarly, line voltage is the voltage between two terminals. Line current is the current in the transmission line. Phase current is the current from the source or current into an impedance. Use these informations. Very important part. The relationships. Okay, in the star and the delta connections में relationship जो होता है ना, so if you take a star connection, in a star connection IL equal to RDH, VL equal to VPH. Okay, and what is the phase angle between this one? VL. For positive sequence बोल रहा हूँ, negative को उल्टा ले, ठीक है. And line voltage and phase voltage का relation क्या? They will be having line voltage leads the phase voltage by 30 degrees. So the line leads phase by 30 degrees. Here delta connection phase VL equal to VPH, IL equal to root 3 times IPH. Okay. Here the line lag, okay, phase by 30 degrees. The line voltage lags the phase voltage, sorry, line current lags the phase current by 30 degrees. IL lags IPH. So both are dual to each other. Okay. And power is equal to 3 times VPH IPH cos phi, where here phi is the angle between voltage of the phase and current of the phase. Don't take the angle between line and line. It can be written as root 3 VL IL cos phi. ठीक है. So yes, complex power S equal to 3 times VPH into IPH conjugate. You should take the angle between voltage and current of the phase only, not for the Fine. These are some basics we should know from the star delta configurations. Most of the questions are repeated from this part only. ठीक है? Let's do few questions. क्वेश्चन तो आसान वाला लेना चाहिए, टाइम सेव हो पाएगा। और क्वेश्चन तो आप लोग प्रैक्टिस कर सकते हैं ना, ठीक है, आप ट्राई कर लो। आंसर्स दे रहा हूँ, ये तो जीरो है ना, हम ऑलरेडी कैलकुलेट किया। ठीक है, ठीक है, ऑलमोस्ट एवरी टॉपिक वी हैव डन with the necessary theory and the problems except three phase circuits में मैं केवल theory दिया, बाकी तो और सारे क्वेश्चन सारे टॉपिक्स में theory problems everything we have done as I have committed. You can see our commitment हमेशा irrespective of the number strength here whatever the number of students present and all that doesn't matter. Every single day irrespective of the works we have, we always uh, able to continue the classes with the discipline. I expect always the same discipline from you students also while studying. आप भी इतना discipline दिखाओ, definitely you can see the difference in the results. Whether it is free or paid class, always we are committed to give you the best content. You can see this ब्रह्मास्त्र बैच में जो lectures मैंने ले लिया ना, so crash के लिए this will be the best. You can see the quality of the problems and the content in the least possible time. Anything if you compare, this will be the best, no doubt in it. So share this playlist with your friends. Definitely, it will be more useful for many students. I hope you will share this and utilize this whatever the sessions we have done. Okay, I will plan some other lectures for digital, not the crash batch, or some other in the next month. We are always there for you guys. We are planning more and more for YouTube also. Okay, so thank you for your time. So आप अभी this ये क्या नया बैचेस तो शुरू हो रहा है, 24 aspirants, 25 aspirants है तो you can take the subscription with us. You'll get 23% off on Unacademy subscription. This is the new year offer for you guys. So IRMS का बैच भी है अभी. Those who want to prepare for IRMS, we are with the CSC and IRMS civil services का अभी preparation मिलेगा with the civil services educators, and this combo offer you can take it. That is the IRMS and the civil services together subscription ले सकते हैं आपने. Use my code for maximum discount. ठीक है? So if you want exam like experience, please enroll to this exam which is available in the link of video description. This will help you what we call to get the real time experience. आपको exam के बाद immediately आपका rank मिलेगा, आपको video solutions मिलेगा, detailed analysis about your performance, where you are wasting time, everything you will get. So don't miss this. All the 4 weeks, please attempt this exam. It will help you while writing the main exam. You will be already habituated and you already avoided the silly mistakes which you need not do in the regular final exam. Okay, thank you very much for your time, guys. I'm happy to announce that this course is complete and I'm able to complete the total syllabus on time. Okay. Thank you very much. As I committed in this year itself, I'm done with this. So next year we start with more and more courses. I wish you a very happy new year for all of the students who are here, guys. Next year, definitely this year you are going to crack the exam. All the very best. So wish you a very happy new year. So we'll meet again in the next year with all the new initiatives. Thank you. Let's crack it.